The moment the announcement went public, one of the biggest questions in modern physics looked finished. A telescope buried deep in Antarctica had just delivered what seemed impossible. Humanity had finally found direct evidence of the first fraction of a second after the Big Bang. The signal was clean, the data looked extraordinary, and within hours, some of the world's most respected physicists were openly discussing a future Nobel Prize. Then the image started falling apart. What looked like a pristine map of the birth of the universe was not coming from the beginning of time at all. It was coming from dust. Ordinary dust, floating quietly inside our own galaxy. And the worst part was this. The entire scientific world had already believed it. In early 2014, a team known as the BICEP2 collaboration stood in front of the world with a claim powerful enough to rewrite cosmology itself. Their telescope sat near the South Pole, one of the coldest and driest places on Earth, built for a single purpose: to measure tiny polarization patterns buried inside the cosmic microwave background. This radiation is ancient. It has been traveling through space for nearly 14 billion years. But inside that radiation, scientists believed something even older might be hiding. Tiny distortions created during cosmic inflation. The violent expansion event, thought to have happened almost instantly after the Big Bang itself. Finding evidence of inflation would do more than support theory. It would confirm that physicists had correctly reconstructed the first heartbeat of reality. And BICEP2 believed they had found it. Their visual map became instantly iconic. A beautiful swirl of red and blue polarization patterns stretching across deep space. At first glance, it looked perfect. And that image immediately changed everything. Major universities began celebrating. Physicists called it historic. Media outlets rushed out headlines declaring that proof of the Big Bang had finally arrived. For a brief moment, science looked certain. But certainty was exactly where the real problem began. The BICEP2 telescope was not measuring inflation directly. It was measuring polarization patterns in microwave radiation. And that measurement came with a dangerous dependency. The signal had to pass through the Milky Way before reaching Earth. That meant local galactic dust could interfere. Tiny dust grains drifting inside our own galaxy naturally align with magnetic fields. And when radiation passes through them, they create polarized patterns. Patterns disturbingly similar to the exact signature BICEP2 was hunting. The team knew this. Everyone knew this. So they needed one final step: dust calibration. They had to prove local contamination had been removed. And under normal scientific procedure, that verification should have happened first. It did not. Because another telescope was already watching. The European Space Agency's Planck Space Observatory had been collecting better microwave background data for years. And everyone understood what that meant. Whoever published first would own one of the most important discoveries in modern physics. Time had suddenly become dangerous. So BICEP2 moved forward. Instead of waiting for full dust calibration data, researchers relied on publicly available presentation slides showing partial foreground estimates from Planck. Not raw data. Not finalized measurements. Slides. The assumption looked safe. The dust contamination appeared low. The polarization map survived. And the announcement went public. But this is where the failure cascade began. Because one fragile assumption had quietly become the foundation for the entire discovery. The famous polarization image returned again. The same swirling pattern of cosmic structure. The same beautiful evidence of inflation. But now, researchers outside the project started checking the math independently. And one detail refused to fit. The dust estimates looked suspiciously incomplete. Something about the foreground subtraction was wrong. At first, the disagreement seemed technical. Just calibration arguments. Normal scientific friction. Then, independent astrophysicists started rerunning the models. And suddenly, the cleanest explanation disappeared. The polarization map still existed. The signal was still there. But now, nobody knew what the signal actually meant. The exact same image had acquired a new meaning. It was no longer evidence from the birth of the universe. It might simply be contamination from our own backyard. And the larger consequence was terrifying. Because the discovery had already spread worldwide. Universities had endorsed it. Scientific institutions had amplified it. Peer review systems had accelerated around it. Entire branches of cosmology were already reorganizing around a result that might be wrong. This was no longer about one telescope. This was about whether modern science could verify itself under competitive pressure. Months later, the BICEP 2 team entered a joint analysis with Planck. Now the full galactic dust measurements were finally available. And when researchers overlaid both datasets together, the famous image returned for the third time. Same colors. Same polarization swirls. Same perfect cosmic signature. But now its meaning collapsed completely. Every pattern BICEP 2 had attributed to primordial gravitational waves could be fully explained by dust filaments drifting inside the Milky Way. Nothing remained. No inflation signal. No Nobel Prize. No breakthrough. The entire discovery evaporated. One of the most celebrated scientific announcements of the century had lasted only months. But the deepest damage was not the mistake itself. Science expects mistakes. The real damage came from dependency exposure. One of the world's smartest research teams had allowed incomplete calibration data to silently become the foundation for global scientific consensus. The telescope worked. The math mostly worked. The signal was real. But one unnoticed dependency poisoned the entire conclusion. And suddenly, the opening image changed forever. That beautiful polarization map never showed the birth of the universe. It showed how easily precision can become illusion. Sometimes science does not fail because theory is wrong. It fails because trust moved too fast. Dust changed everything.